All right, my amazing students, we're up for our second problem that's very similar to our previous one we did. So example 7 is really similar to example 6. So if you want to try example 7, I highly encourage you to do it on your own. All right, guys, let's get started. So let's look at my problem, which I'm going to try to make a little brighter. There we go. A little brighter. But anyway, so in my picture, I have a segment that starts at the center and extends to the other side of my circle. So what type of segment is segment PS? It is a radius, okay, and that radius is hitting this chord, and it forms a 90-degree angle. So how does PS relate to QR? They are both perpendicular because they hit each other at a 90-degree angle, which that means that it splits up my chord QR into two congruent segments within the chord. So that means that Q to the T is congruent to T to the R, which I'm going to label that over here. QT is congruent to TR, which means their segment lengths will be equal. So that's good to know. So like before, if I know one of them, that means the other one's the same. And if I add those bad boys together, bam, I'll get QR. Or if I know one of them, I can simply double it to get QR. Either way. Okay, but currently I don't know either of those segments. Sorry, I blanked for a second. I don't know either of those segment lengths, which is sad. But do you guys see anything in my picture that could help me? Well, I have my radius. I have a 90-degree angle. Okay, this one had kind of like a triangle drawn in for us. So maybe if I drew my own triangle, it would look very similar to this one. So do you guys see a way that maybe, like in this problem, we had a radius drawn in for us that helped us form this nifty 90-degree angle in our triangle. So it formed a right triangle. Do you guys see a way that I could draw a radius in here to form a right triangle? Because if so, then this would flow very similar to the last problem. Do you guys see anything? Okay, well, there's two options. You're probably like, dumb as long. There's two ways to do this. Well, I know. I just wanted to know if you guys saw it. Sorry, guys. Don't get all mad at me. Okay, so there's two ways you can draw this radius to form a right triangle. You could draw it this way and form a radius right here. Whoa, need to do that better. Okay, we could form a right triangle right here by drawing in a radius, or you could draw a radius from P to R. So I drew one in from P to Q. You could also draw one in from P to R, like this. Okay, which that means, don't forget, you guys, if that's a 90-degree angle, since these two angles, angle PTQ and RTP, sorry guys, PTR and PTQ, since both of those form a linear pair, they form that nice line right there. If one of my angles is 90 degrees, the other one is also. So if you guys see, I have two right triangles, which guess what, you guys? It doesn't matter which one I use. So, I don't know. I'm just going to use the one on top just because it's speaking to me. So I'm going to be using this right triangle right there. Me and this triangle, we had a conversation, and we're on good terms. So I'm going to use that triangle right there. Guys, so I know that segment PT is 10. Okay, and since PQ is a radius, remember, all radii in a circle are the same length. So do you guys know the length of one radius of the circle? Holy hot dog. PS is 10 plus 10, which is 20. So I know PS is 20, which means that PQ is 20. Remember, you could also say that PR is 20 as well. So I'm going to label that bad boy as 20. Alright, guys, and since we have a right triangle, we can get the show on the road. Let's get going. So I'm going to draw my right triangle off to the side over here. See if we can get this back to the way it was. Jeez. Okay. So I'm going to draw my right triangle off to the side. So this bad boy looks like this. Bam. Bam. Shazam. There we go. Alright, so this is triangle PSQ, or no, PTQ, sorry. Demon cats are getting me tonight. Jeez, you guys. Alright, and I'm going to fill in my lengths of each side. So PT is 10, and I don't know QT. I'm going to leave that one alone. This one I don't know. And then PQ is 20. So guess what, you guys? How do we find the sides of a right triangle? We do, in fact, use the amazing Pythagorean theorem. So I'm going to get that started. So remember, we have our a squared plus b squared equals c squared. All right, and remember, you guys, the a and the b form the sides of the right angle on my triangle, which is PT and QT. So I'm going to label this one PT as A and QT as B. And then C is the side across from my 90-degree angle. So this is side C. All right, let's get going on this. So my A is going to be 10. So this is 10 squared plus B squared, which I don't know. So I'm going to leave it as B squared, equals C squared, which is 20. Bam. All right, so let's start simplifying. So 10 squared, 10 times 10 is 100. Plus b squared equals 20 squared. 20 times 20 is 400. All right, let's solve this bad boy for b. How do I move a positive 100 to the other side? You guys are just brilliant. I would subtract it on both sides. So 100 minus 100 will cancel and turn to 0. 400 minus 100 will turn to 300. So we have b squared equals 300. All right, guys, we're almost there. How do we undo the square? What is the inverse of a square? It is a square root. So I'm going to square root that thing on both sides. Bam. And the square root will cancel out the square. So I'm left with b equals the square root of 100, which I'm trying to think. What times what gives me 300? It's not a perfect square. There's nothing I can multiply it to itself to get 300. So what do we have to do with the radical, you guys, when it's not a perfect square? How do we save it? We do have to do our nifty factor tree. So I'm going to do the work for that over here. So I'm going to do my little factor tree. I'm going to break it on down. All right, so 300 breaks down into, I don't know, let's see here, 10 and 30. Why not? 10 will break down into 5 and 2. All right, and 30 will break down into 3 and 10. All right, and 10 will break down into 5 and 2. All right, so remember when we simplify down our square root, we want to try to find the cute little couples at the ends of the branches, which I tried to do them in 2 different colors so you could see a little better. Right now, I know you can't really tell because I wasn't thinking through this, and I used 2 shades of purple. So sorry, you guys, but we're looking for the ones at the ends of the branches, so the ones that don't break down. So that'd be like the 5, the 2, the 3, and the 5, and the 2. So do you guys spot any cute little couples that will leave the house to go on their hot math date? Oh man, I see some too. I see a pair of 5, so I'm going to circle those bad boys right here. So I got a pair of 5s. So for each pair, one will hop outside of my square root, which I didn't plan ahead. I did not leave enough room, so I need to redo this. Sorry guys, let me leave some more space. Okay, so I have one pair of 5, so that means one 5 will hop outside my square root. All right, and I see another cute little couple that gets to go on their hot math date. I see a pair of 2s right there, which means 1, 2 will hop out for the couple. 1 represents the whole couple. So, and remember you guys, when you have more than one number outside of your square root, you multiply them. So 1, 2 will hop outside my square root. Now, do you see any lonely single numbers that don't have a cute partner to go on their hot math date with? This lonely 3 right here. So this 3 is going to stay on the inside of my square root. I'm hopeful, though. One day it will have someone to go on their hot math date with. I'm confident. Okay, so I'm going to simplify this down. So b equals 5 times 2, which is 10, and then root 3. Okay, which b is secretly QT, so I'm going to label it as QT. So this is kind of cool, you guys, because we were talking about cute couples going on their hot math dates, so they're cutie. Get it? QT. Oh, that's a board slapper. I cracked myself up. So QT, the length of QT is 10 root 3. That's 10 root 3. I know it's not very clear, but we are not done. The problem says to find for the length of QR. But I do know that QT and TR are equal in length. So that means that QT will equal 10 root 3 as well as TR. So QT equals 10 root 3 and TR equals 10 root 3. Alright, so now I can use this information to help me find segment QR. And using the segment addition postulate, I can break up QR into two nifty segments. QR will equal QT plus TR. Alright, let's fill in these values and then we'll be done with this problem. Let's go. Alright, so QR equals QT, which is 10 root 3. Nice. Plus TR, which is also 10 root 3. All right, now we have to be very careful when we simplify this, you guys, because square roots can be a little tricky, and I'll explain why. So square roots, first of all, you can only add square roots if the number inside the radical, which is called the radicand, those two values have to be the same. Okay, so I can't add like root 5 to root 3 because they're not the same. But if you guys see here, root 3 and root 3 are the same. Okay, and when we add these, you kind of think of the root 3s as like terms. So they're like the variables in the problem. We don't change the radical. So my final answer is going to remain as root 3. I'm not going to change that. So QR will equal the root 3 stays the same. I do not add the root 3s together. If you do, the demon cats are coming for you, so you better watch it. Watch it. Guys, in like terms, when you add them, you add the numbers in front of the variable. So we're going to treat root 3 like a variable. Okay, so I'm going to combine the 10s together. What's 10 plus 10? It is 20. So Q to the R is 20 root 3. Wasn't that problem super exciting, you guys? I know, I agree, like normal. That was awesome.